So made a ROT13 folder. Okay. So let's see. Start a listener, accept connection, scan it line by line, 2 lowercase, and then convert to bytes, and make a new 13 bytes, and move over each byte, and then do this, and then print it out. So let's see what happens when we run that.
You get in an encryption heaven, baby. Nobody's gonna know what you're thinking anymore. Emails, everything, encrypted. It's simplicity.
That's probably right.
Type in Gerfug again.
Oh yeah, it's the neat thing about ROT13 is it's the same backwards and forwards. So yeah, it seems to work. Is there a reason why you did 2 lowercase?
So I was just working with the ASCII numbers 97 through 122.
Okay. Because I think you can do uppercase too. Yeah, that works.
No, it's hard coded for the ASCII.
You want mine?
It goes from, yeah, I want to see yours, Daniel. Daniel!
My goodness, where's my cake?
You can hit Command Shift V in OS X or Control Shift V to paste without formatting in the browser. Okay, go to handle connection. Go over each byte. It's very similar than the other one, but this one also has the uppercase. But otherwise, pretty much the same. So either of these work. I want to show a slightly different way of doing it because it's interesting. So, one of the issues with this is that it's sort of embedded in here. It's a little hard to see what's going on. And so an easy change would be to make this a function. And so that you could do ROT13, give it the string, and it would give you back another string that was ROT13. But there's another way we can solve this using a reader. So the idea is that I'm going to do this. I'm going to make a function called ROT13. It's going to take in a reader and return a reader. So it takes a reader and makes it, now when you read from it, it gives you ROT13 stuff. But otherwise it's going to do exactly the same thing. So the way we're going to do that is I'm going to make a type called ROT13 reader. Okay, inside of it, it has a reader. And then we're going to override the read method. So we'll call it ROT13. Read takes in, I think, like this, if I remember right. So we're going to create our own reader that implements a read interface. We'll call the underlying one. Okay. So this returns like this. And then at the end we'll return the same thing. But in the loop here we'll just say like this. Oops, that's the wrong one. So for IV and range BS, this is P here, and it's P to N, but otherwise the same. Oh, these all need to change to P. Yeah. So here we just say ROT13 reader. Okay. So an alternative way of solving this problem is we use our IO copy. Remember that from the other echo? The place we're putting is con. The place we're reading from is now we just say ROT13 con. Okay. And the idea is that I made a reader, and when you read from that read, it transforms the underlying reader into ROT13. Okay. And so it calls this. It'll call connection.read, take that data, ROT13 it, and then return it. So this is another way of solving this problem. This one leads to easier code on this side. So everybody following this? Any questions about this?
Yeah, you just copy paste it up to scratch.
So basically the idea being that you can create your own reader, and sometimes it makes your code easier on the other side. You know, we can create a 2 lowercase reader that takes a reader and 2 lowercases everything when you read from it. Or vice versa, we can create a 2 lowercase writer that takes in a writer. Anytime you write to it, it first lowercases it and then writes it to the underlying writer. So you can do it on both sides. But that just makes this easier, that's all. But otherwise, the other code was fine. It was perfectly fine. So chat server, I think we'll do this one together because I think it's a little challenging. But it's a really interesting program. So the idea is that I'm going to create in day 2 here, chat-server, and it's going to have a main function. I'm going to copy this guy and just paste him in here and swap out, get rid of all this 13 stuff.
Can you scratch? Did you already clear on scratch?
It's up on, it's up my place.
We're just going to replace the code in here. So this is creating the listener and it's handling the connection. So the code is in here. And the idea is that, like in the other example where we had this we had that Redis server, we're going to create our own chat server. So I want to create a type chat server. And what does a chat server have? So imagine the chat server is just a single room of a chat server. Okay. So you log in, you give yourself a username or something, and then you type messages, and everybody else can see those messages.
So it usually has a lot of profanity,
Right.
hostility.
Those are the things you have to add. We're just making the plumbing behind that. So.
Oh, okay.
So we might have users is a map of, say, username to user. So we need a type for user. So we'll add the details for that, but it'll at least have name. And so we'll use that name to go inside of our map. And then we have to have some way of knowing when a user joins. So we'll use a channel for that. And that's a channel of users. So that means a user joined, that's that channel. And then we'll have a leave, when a user leaves. And then, what's another event, if you will, that we need?
Communicate.
Communicate, we receive a message. So let's say input, we'll call that input is a channel of string. Though, if we do it that way, we don't really know where it came from. We don't know who said it. So maybe we should have a struct for message, and it would just have, you know, user as a user or something, and, or actually we could just do username. And then we would have message, or let's just call it text string, okay? And that, so we'll take that instead. That way we just know who said it, that's all. And so we're gonna have these 3 channels. For output, we'll see, well, how would you do output? So we got input, we can receive messages. And the idea is that our chat server will do whatever it needs to do and then send those messages to group. So how do we do that?
Are we going to be doing this through Telnet, TCP, that kind of thing?
Yeah.
So would we want to just kind of like thinking about the user interface, because you enter things and then after you've entered it, your entry point doesn't always stay at the bottom, right?
So we'll get back to it, and I'll ask in a second. So I'm going to make a run method, and this is going to do all the logic needed for our chat server. Okay, so it's like we have the chat server process running inside of our program, and then the other things are going to connect into it and come back out to it, just like we did in that other example. And so I make a for loop and a select. Okay, this is a very common pattern, the for select. So the select here is every case. So I have a case, the user joins, so that's cs.join. And then the user leaves. And then the case where I receive a message. Input. Okay, so those are like the three cases. I have a user join, a user leaves, and then I receive a message. And the idea here is that inside of here, what am I going to do inside of join?
I'm going to add a name to the display of who's in the chat room.
Okay, so we want to say someone joined. That would be a good thing to do. What else do we want to do?
What do you got?
We need to update our list or map of users, right? So I'm going to say cs.users at user.name equals user. So that way we have them in the list. So what's the side effect of that? I mean the other side of that, so we say someone leave, we're going to want to do that. We haven't implemented that yet, but we will. But what do we need to do to our map? Yeah, English there.
We all have our areas of expertise.
So we say delete, right? cs.users and user.name. Okay? And that's going to keep track of our map. So we'll know every user that's joined and every user that leaves. We'll know when that happens. And then in here, we're going to want to do a loop, right? We're going to loop over every user and send the message to that user. Okay, that's going to be the basic idea. So I'll just call it user to be consistent. I'm going to do something like user.send message, right? Like how do I do that? That's what we want to make, right? And the message here is going to be just message, right? How do I do that? That's what I'm trying to implement, okay? And how I'm going to do that is I'm going to add a channel to user. We'll call it output. And it's a channel of message. We have our input, this is our output channel, okay? It's a one-to-many thing. I get one message and I send it to all the users so they get replicated to every user. That's what this for loop's doing, right? So instead of saying send message here, I'll say output and takes message. Everybody following the basic structure here?
Yeah.
I forgot range. So that's our chat server. How are we going to do these? Say someone joined. So the way we can do that is we have available to us input, right? So we can say input takes, and then we'll use sprintf, %s joined, and then we'll give it the username, so user.name. So that's going to say Joe joined or whatever. Right, it needs to be a message. So, you know, as far as from who it's from, that's kind of complicated, right? Because the username is, this is a system message, so we'll just say system. And that's typical in chat apps, you'll see that, right? The room set it, which is kind of a weird idea, but that'll give us our message. And then we'll do the same for left, but what's wrong with this code?
Race condition.
There's not a race condition.
There's a guess. There's a guess.
That's a good guess, but it's not for this one. The issue with this code is this never happens. This can't happen. It'll just sit here waiting forever. Because the only guy reading from input is down here, which is himself. So he's going to try to push onto input, and nothing can happen. Because he's waiting for something to be on the other side to pull off of this guy. But that doesn't happen until the loop goes around again. So we need to put this in a go routine.
In a go routine.
We say go function. Okay?
And then the loop continues on.
Then the loop continues on and goes here and then pulls off the message just put on. Okay. And so we need to do the same for left, not leaved. Left. Okay. So we did that. So now, when a user joins, we go here and then we say someone joined. Notice that that person who just joined is going to get that message, which is cool. That's probably what we want, right? Because we've added to the list of users. And if they leave, then we say that. So what do we do to our code over here? Well, first we create our room. And we have to initialize all this stuff. Sorry, let's call it chat server, just to be server. And then we need to initialize it. So users is make map, that thing. And we can just copy this. And so on. Now we need the commas. Colon. Okay, so now we have a chat server. And then we say, how do we start it?
Run.
Exactly. So we say go chat server run. So now it's running. Okay, so now it's ready to handle input from the user, right? So we need to change handle con here so that it takes in that chat server. It's a chat server. And then we say, what's the first thing we do? So at this point, I have a new connection. We probably want to join, right? Right. But how do we get the username? Well, we're going to have to ask the user or something, right? Because user up here is a name and then this output channel. So what I'll probably do is like this. I'll say user is a user. We'll say name is just test. We'll add that bit later. And then output is a channel, messages. And then we do join. Okay. Now we'll do the bit about reading from the next part will be that we want to send all the messages from the connection to the chat room, to the chat server. And we want to read everything from the chat server and send it out the connection. But at the very end, what do we want to do? Leave.
Variant, you said, what do we want to do?
Yeah. We want to leave, right? So we would do that like this.
You defer it.
Yeah, probably. So remember, it has to be a function, so. But we can defer it. So that's a good pattern, right? I do the join, and then I'm going to defer the leave so that I don't forget to do it. And then I'll do all the logic in my code. And so inside of here, we're going to have to do two things. We have to do the reading from the connection and the writing to the connection. So the reading from we can do in a go. Right? And so we'll put a comment, read from connection. We'll just say a message is a new line, is a line of text, right? So we can make a scanner, scanner, give it con, and then for scanner.scan. Now we have a line. Text, that's it. And so now we can send to the chat server the next message. So we can say .input takes, and we have to give it a message. So we say message. The first thing is the username, so we say user.name. And then the second thing is an output channel. Oh, sorry, is the message itself, right? Is the line, okay? So now we are reading messages from the connection and we're sending them to the chat server, right? And so you can see that, right? Here's the reading, the scanning, and then we're sending. You can see that in the code. And then the second part is write to connection. And so, what's that? How do we do that?
If you do the format print, fprint connection,
Well, what are we sending?
so you would send a message.
A message.
From output, user.output.
Exactly. So for message range user.output, right? So every time we're getting a message, we're going to then print that to the connection. Okay. So we're going to say, IO.write string. message.text. Or, maybe we'll say message.username plus colon plus, and then it'll say, Joe colon the message. Sorry, write string. And then right. So down here I had to add chat server. Okay. There's some issues with this, but does everyone understand the basic idea here? So I have a connection, I come in here, I'm going to join the chat server, eventually I'll leave the chat server, I'm going to start reading messages from the connection, and I'm going to write them to the chat room. Sorry, I got it backwards. Write them to the chat server. And then I'm going to start reading messages from the chat server and writing them to the connection. Okay.
So my question now would it be a good idea to close the user.output up in the reading part?
Yeah, so there are two ways we could do that. We could do that in here somehow. That's not a bad approach.
Can you cover this over before you change it up, just like version 1, please?
Or, we know when the connection disconnects because this will return an error, and we can look for that error and then do something to close the output. But let's just see if this works in its current form, and we'll fix it. I think it at least should run. Control C. What did I call this? Chat server. Okay. Test joined from system. So I connected and it immediately gave me a message that I joined. And then if I send it text said text. So it does seem to be working. Now let's add another user. It's only one. Should be going to both of them. Oh, it's because they have the same name. That is an issue. You see why it didn't work? They had the same name. So when the other user joined, he replaced the first one because this replaces it. So we need to get their names. So let's just do.
Could that be a telnet argument after the 9000? Telnet allow that?
No. Let's do it this way. So I make the scanner. We'll just say the first line will be your username. So we'll just say and then this is just, scanner.text. And then the scan line gets the, okay. So all I did is make the first line will be the username. That's what we'll use in here, okay? So kill this guy, reinstall him, and connect. We'll call this B over here. So B joined, and then we'll run it over here, and A joined. Ah, we got a message over here that A joined. So if I start typing, A said test here, A said test over there, and I type over here, B said test. Now we have an issue, we should add some new lines because that's super confusing. That's very easy, right? We just add it here. And that'll put some new lines in there. Let's try that again. So this is B, B joined. This is A joined. We type test, test shows up over there from A, and test shows up over here from B. So we made a chat server, a basic chat server. Everybody following?
That's awesome.
Okay,
Can
so.
you copy that over, please? Thank you. Thank you very much.
Okay, so this does have issues, and I think I can make them happen. So let's say B disconnects. Quit, B disconnected. Notice I didn't get B left over here. So that's a problem. There's a bigger problem. Interesting that this is still working. Oh, yeah, I guess it would still work, but there's actually a big problem. So we didn't get the B left. The reason why we didn't get B left is this never happened. The reason this never happened is it's still inside of this loop. Okay? But the connection's closed. So it's trying to write all these messages to B's connection. We've got disconnected. And it's failing every time. This is returning an error. But we're not doing anything with the error. So we just keep trying. And so what would happen is over time, if we have lots and lots of connections, eventually we would have way too many. We'd have all these orphaned connections which no longer exist. Okay? So that's a problem. There are a couple things we could do. The first might be this. This is the example. We check the error is not nil, then we break. And that way the loop stops. So if we try to write it and it fails and the loop stops, and theoretically, right, we leave. Because then it's going to get to the end of the function and finish. So let's see what happens if we do that. So A is over here. B's over here. B joins. B can type and stuff. I exit. Okay. Still no B left over here. Oh, there it goes. It took a message to make it happen. Because otherwise the for loop doesn't happen. Okay? So once a message came in, then it tried to write it, then it failed to write it, then it breaks. And then B left over here. So we did eventually see the B left. I think there's an issue with this code. But maybe it doesn't matter. So I think the issue with this code is that there is a delay between like when this happens and when this happens up here. So it receives the message here and then it tries to write it out. But maybe it doesn't matter. So what I'm saying is we might add to here this case and then have a case with a timeout. And basically, if after 10 seconds we fail, or whatever we wanted to set the time is, we would move on. Okay. And that might be good so that if,
52, what's that doing there? It almost looks like you're putting that on a channel or what?
this creates a new channel, and after 10 seconds, it sends a value. So the select here is either I send it to output, or for some reason that doesn't work. After 10 seconds, I give up. It goes back here, goes back to the for loop, goes to the next user.
And so how does that create a channel? Why would you need to do that there?
That's how we implement a timeout.
That's just how you do a timeout.
Yeah, we covered this, I think. So why would you want to do that? Because otherwise this is going to sit there forever until it's able to do it. And I think there might be a case where that can happen, is what I'm saying, given the way this loop down here is written. So I wonder if that's a problem. In other words, we do user output, we break out of the loop. User output is still available. It's still sitting in the server. So the server can try to write a message to it, even though this for loop's not happening anymore, so nothing is ever going to read from it. Okay? And so it would just wait forever, even though nobody's ever going to read from that output channel. And that's not a good thing. That means our whole server could lock up. Now I'm not sure how to make it happen, because it requires careful timing for it to happen. So another option is to use a buffer channel. So if you give comma and asides to this, I've now made a channel that can hold up to 10 messages. And so when I try to put something onto it, if there's space available, if it say is empty, it'll put it on right away and go to the next thing. So instead of waiting for something to be available to pull off of the channel, it's now going to allow me to put up to 10 things onto the channel without blocking, and then the 10th one it's going to wait. Okay. Now, if on the other side I'm pulling messages off, if there's something available, I get it immediately. Okay. So it's like this allows you to, I don't know, instead of handing a letter directly to somebody, you can put it in a box and they can pull it out of the box. Okay. And you can move on your merry way. That's kind of what we're doing with the buffer channel. So we can use that and change our timeout here. Instead of doing a timeout, we don't need to wait. So this, now it'll push the message on there. Even if nobody's on the other side reading it, it's going to push it on because there's space for it. There's 10 slots available. Just throw it in there. But we need to make a change to this. Say it is full. Say there's 10 messages. How do we do with select statement? How do we? If I always want to finish, if I don't want to wait, what do I do? Default. So now what this is going to do is, if there's space available in the output channel, it'll put it in there. If there's no space available, it skips it and moves on. And so now what we've created is, if I have a slow reader, the guy's sitting there who's unable to, the connection's broken or something's weird's going on, he can get up to 10 messages in his backlog. But after 10 messages, it just starts dropping them. He's not going to get those messages anymore. Okay. So this is another approach, and I like this one a little better because it's a little. I don't like having to use a timeout, so this is a little cleaner. But anyway, that fixes the chat server. But as we saw, the first version did work. It just had some slight bugs that may crop up.
You copy that over too, please.
So any questions about this?
Oh, one question. I don't want to go into this, but if you're pushing it to a server to save or whatever, it wouldn't be a safe server, right? And the other question is, are you going to append it to a giant file, or are you going to, if you were going to do it, would you send it to a database?
Yeah, there's no need for a database here because it's all just in here. So,
it stays on that server.
yeah. I mean, it's a chat server.
But I mean, for a record,
I mean, we could do that, I guess. You'd log every message, but I don't think we need to in this example.
I don't rather do it. But, so you can't serve it right there. Is it going to be like appending to a big file, or no?
No. So maybe I'll walk through the logic again. We created a chat server. I accept a connection. It goes up here. First thing I do is ask for your username. Does everybody understand the username asking that? That's pretty straightforward, right? I print enter your username, and then I read the next line they enter, and I use that as their username. Okay? Then I tell the chat server that this user joined. This goes up to this join, and it happens right here. Okay? So it sets that, it puts it in the dictionary, in the map. And so now I have a user inside of my map, and then I am going to cause a message to happen later. So I put this in the background, I'm going to run this thing that pushes this message. So that's happening later. So then it goes back to the for loop and select, and it's going to sit here and wait until something happens. It just so happens, since I started this in the background, that now this thing down here happens, okay? So I get a message, and then for each user, I try to push that message onto the output. So if we go back down here, while that's all been happening, he's gone down, he does this defer thing later, and he starts reading text from the user, okay? So right now he's waiting for text input, so there's nothing happening here yet, because this is still waiting. But he gets down to this loop, and he reads from the output. So what if we just put on the output? We just put on the output A joined, right? That's what happened up here when we did this. So we read A joined from the input, and we put it onto the output. And so now, down here, we just read A joined, and we write it to the connection. We say A : space joined, and end it with a new line. Or I guess it actually says system, and then it says A joined. It's the text. And then we loop back around waiting for the next message. So if I enter a message, what happens when I enter a message? It goes here, reads that as a line of text, sends it to input. Input's up here, so it gets out of here, it goes here, message. It loops over every user currently in the room and sends it to their output channel. So it goes back down here, reads it on the output channel, and sends it. Okay. So, everybody following the flow of how messages go between the two? Okay. So that's how you make a chat room in Go. You have to use channels and messages. You could do this with locks and a single for loop if you wanted. I think that would end up with much more confusing code, but you could do that.
Do we need this? Do we need the echo here? Like whatever you write is if it's like echo to.
This is very much like Echo, except all we've changed is now instead of it sending it to one connection, it sends it to all of them.
I'm just thinking like I'm adjusting the chat, and whatever I write, it's like twice. When I see like what I wrote, and then it says Eunice or whatever.
That's right. It sends yourself the message.
That just has to do with telnet. So, I mean, the telnet client without my phone is not repeat whatever I put into it.
You know how we can fix that? What if you don't want to see your own messages? It's really easy to fix. Only send it if it's not me.
Can you also put in line breaks so that it moves it off to the left and put a new one? 'Cause right now, in my windows, it keeps adding off to the right.
He's got that on line 85 at the very end.
Oh, there. Well, why is it not going to the left side of the command window?
I don't know. It does on mine.
I got two different servers open, talking to each other, it's doing it on both of them.
Yeah. So now it says test join. I type test, I don't see anything.
Okay.
The reason I don't see anything is because I filtered it. So now if I have B over here, system B join, he writes test. It shows up over here, B wrote test. I showed test over here, now it says test wrote test. So I'm only seeing messages that aren't from me. How did I do that? I just used an if. It's really easy. I said if the message username is not my username, then show it. If it is my username, then that means I sent it. I sent it up here. So I don't care about that message, I just drop it. Okay? So that's how you make a chat server. Okay. Our next topic is, that's sort of it for the TCP servers. We could keep making TCP servers if people want to, but our next topic is we're going to try to build an HTTP server from scratch. Okay? But I think that's more than we have time to do. So if you guys want to keep working on some of these programs, I can help you. And after lunch, we'll come back to HTTP server from scratch. Okay?
Can you copy up that last bit? All you